Hello everyone and welcome to the third session of week 12 of our NPTEL course in pharmacognosy and phytochemistry. Now this week what we are learning are set of computational tools that will help our knowledge or help us gain more knowledge in the stream of pharmacognosy and phytochemistry. So in the very first session we saw that how we can observe and study which all plants do we choose for our research, what plants do we see, can we compare it with herbarium sheets present universally into this databases and understand the taxonomy of these plants. In the second session where we saw about the utility of these plants in traditional medicines, we saw that how different databases are curated to accommodate the drugs present in traditional medicines, know their properties and help us translate so that we did not go to Sanskrit or other scriptures and we can get the deep understanding it right from the servers itself. In the session 2, what we saw is how we can use the servers or databases to see the different phytoconstituents that are present. So if you recollect your week 1, we saw databases such as your Plant of World Online, Jastor, Tropicos, New York Botanical Gardens, herbarium sheets, and then we saw some traditional medicinal plants containing databases. Do you all recollect? It was your traditional knowledge digital library. Then you had your MPPAT, as well as we saw Indian medicinal plants database. In the last session, we saw few more servers and databases which helped us in phytochemical searches. This were your knapsack database, Dr. Duke's database, PhytoHub essentially for food based ingredients, coconut databases which gave us phytoconstituents along with the structure, IMPPAT which also gives us the phytochemical correlations of the plant, IMPPAT also gave us the therapeutic applications. If you recollect, there were two windows, one pertaining to phytochemical and other pertaining to therapeutics. In addition to that, we also saw the Aushadhi database, and Aushadhi database gave us the whole thing like the phytochemicals, the therapeutic application, it also gives us the chemometric database. Now in today's session, we will move a step further. Now we got the plants, we got the pharmacological activities especially with respect to traditional medicine. Now we got the phytoconstituents. So today's session will be seeing different servers or web based applications that are going to help us analyze the phytoconstituents in terms of their properties. Now understanding the properties of phytoconstituents are very important in terms of their application. So I should know what they are soluble in, maybe something about the molecular weight, something about the structure, the orientation. All of this information is vital when I have to go a step ahead and do some chemical reactions or use those phytochemical as pure compounds for analysis. Not only that, these pure phytochemicals have numerous applications in biosensors. They have been used in therapeutic studies, especially molecular docking studies where the structural attributes play a vital role. So this session particularly emphasizes on understanding phytochemical properties of the phytoconstituent. So today we are going to use few databases and web-based searches. This includes your PubChem, your Lotus, Zinc Natural Product Database, NP Atlas or Natural Product Atlas, Dictionary of Natural Products as well as NP Scout. So let's see each of the search engines, what they have to offer in terms of structural information of our compounds. So we'll start with the PubChem database. Now PubChem database is a database which is not selectively a natural product database. It is a database which is pertaining to natural as well as allopathic medicines as well as non-medicinal molecules as well. So it helps us give a curated information about the molecular properties, about its spectral characteristics as well as its metabolism. So let's first see the PubChem database, which is non-specific, and what it has to offer for natural products, especially the phytoconstituents. So when you search the PubChem database, you will land up on a page like this. So you have this, which is run by a National Library of Medicine, and you will find a search, that is explore chemistry based search, and here you can put in your queries either as a name or a structure or even a molecular formula, or even what is called as the 2D format. We call it as a SMILES notation, or even INCI number. So let's just simply put a molecule called as quercetin, and let's see it's already started running with the queries. So I'm just clicking on quercetin. Now when I click on quercetin, it has come up with quercetin, and it says that this quercetin has 701 compounds. Now what does that mean? That means that this quercetin, which is a native nucleus, is part of a nucleus of many other molecules, and this many other molecules could be simple quercetin or they are glycosides. Can you see there? You know what glycosides are, you remember, when they are complex or when they are condensed with a sugar. Gentiobioside, sophoroside. You can see here the list is enormous, almost 701. Many of the cases you might even come across dimers of quercetin. So it will just take this query as one search, and where all it will find a very similar structure, it will return back to you with all such similar structures. So this is a very elaborated list. So let's just simply quickly click on quercetin as a native molecule. Now when I click on quercetin as a native molecule, you can see towards this side whatever the site has to offer. So you will see PubChem gives you information about structures, name and identifiers, chemical and physical properties, spectral information, chemical vendors, the suppliers, drug and medication, food additives, pharmacology, use and manufacturing, identification, something to do with the MSDS, that is safety and hazards, toxicity, any associated disease, some literature, patent. Kindly understand here the elaborate literature is not brought in, just pertaining to the structural attributes. Interactions, pathways, biologicals, taxonomy, classification. So you can see it is giving you a whole chemistry in one page. So you can see here, if I just see quercetin, I can click here. I get what is called as the 2D structure of quercetin, wherein the heteromolecules are marked by different color. Now if I have to use, like I said, many a times we see phytochemical structures, we want the coordinates of it. You can download these structures. So you can see the different formats are available for this. You can also see the quercetin, how it occurs in nature, mostly in the 3D format. You just keep your cursor here and you can enjoy beautifully how this molecule occurs in nature, and the most what is called as energy minimized or the most stable conformation in different forms, that is the ball and stick model, just the stick model, wire and frame model, or even you can see it in the space filling form. So you can appreciate how the flavonoids actually are there or are localized in that. Now we go to the crystal structure. These are all the crystal structure records. Now what happens is when you purify any phytochemical, it will not always set in one particular crystal conformation. Now depending upon the solvent, depending upon the temperature, depending upon its state of hydration, depending upon what all interactions it is undergoing, you might come up with different crystal forms. So all this crystal structure details are brought in here. So these are brought through your crystallography open databases. Then you have your descriptors. These descriptors are the ones which are used to annotate it. This includes your IUPAC name, INCI or basically INCHI name. Then your key, this is just an alphabetical representation of that. Then the 2D format of the structure, which we call it as the SMILES notation. The molecular formula, CAS ID, that is the chemical abstract ID. Then you have your EC number if it has any. Sometimes some compounds do have, sometimes. So what all numbers it is all identified with will all be seen here. You can see different ID, drugs bank ID, toxicity substance ID, HMDB ID, KEGG ID. So all the different IDs, whatever this molecule is there in those softwares, by which number it is there, you can see those numbers here. Then you have the MESH entries, which is often used to search literature, the synonyms of it, the physical properties. You remember physical properties and the computated properties, which include the molecular weight, log P, which is the lipophilicity, how much hydrogen bond acceptors the molecule have, how much hydrogen bond donors. Now this is necessary for interaction studies, how much flexible it is. So it just has that one rotatable bond we saw, that is the B ring rotatable bond. The exact mass, isotopic mass, that is, this is the total polar surface area, how polar the molecule is, how many heavy atoms does it have. So you can see color. This, so many a times you might come across a brown color substance in nature and you say that I have a purified compound. But when you check your PubChem, you see your quercetin, if you are purifying, if it is brown, it is not your purified quercetin. Your purified quercetin should be present as yellow needles. The boiling point, in this case it is not boiling, it is actually subliming. Melting point, solubility, the drugs bank details, optical rotation, decomposition. So you can see lot of properties and other experimental properties are there. Now we go to the spectral data. So you can see if this analyze. Now this is basically not a data which is kind of reproduced. This is a data which is calculated by servers. So it is calculated that if you use a 600 megahertz quercetin, this is the kind of graph you are going to get in terms of ppm. Now this is particularly for the region between 6 to 8, but definitely you will see some of the peaks beyond this region as well. Then your C13, remember this. Then your 2D NMR, especially you see your HSQC in this region, where your proton and C13 NMR are brought in together. Then the mass spectroscopic details, especially the GCMS, what all peaks it will show in terms of its fragmentation. So this is one of my go-to databases when I search chemical properties of any phytoconstituent. This is a database, like I said, it's just not pertaining to natural products, but it's a very exhaustive database. So most of the chemical information that you require about any of this molecule, you will see it here. And not only you will see it here, it's very accurate here. So the fragmentation peaks, the UV spectra, typical flavonoids at what nanometers. So we said the flavonoids have two peaks, band 1, band 2. So you can see here the band 1 is 373, then you have a small hump here, and again you have your band 2 at 256. The IR spectral detail is not there, but you can see the FTIR. So you can see the list is so exorbitant. who supplies this compound in case if you want to purchase it. So your PubChem kind of makes the whole details ready for you. The metabolism, the drug indication where all it is known to be used, age related macular degeneration or Alzheimer's, childhood cancer, hepatitis, they are almost different entries here, and at what phase it has reached, that also it gives you the detail. The summary, whether it is toxic especially to your liver or not, the drug labels. So we just reached to a 7th point. So understand the kind of depth this kind of server gives you. Drug warning, biomarker where it is seen in case of particular disease, food additives, associated food which will also give you this compound. The pharmacology, any reports pertaining to the pharmacological use of this. Metabolism, what happens to those if you consume quercetin. See, that's why I said when you're doing literature you can get this servers help you out with the whole thing. So I need not study this again. I already know what is my quercetin going to be metabolized into just by browsing through this softwares. The biological half-life, what is the mechanism of action, the biochemical reactions of that, transformations, uses mostly antioxidant is what it's used for, methods of manufacturing. So if you're thinking of synthetically producing it rather than taking it from plants, this kind of server gives you that as well. Formulations, manufacturing information, then you can have your laboratory, safety, hazard categories. Like I said, your MSDS data is also partially here. Then what do you do in case of accidental release when you are exposed to it? The storage condition, stability, is the molecule stable or not? Transportation, any regulatory information, toxicity information, carcinogenicity information, acute effects on mice, it's seen, interactions with any drugs or any other substances. So you can see, like I said, this one software is like a whole package for your literature. That's where it's mostly a go-to software if you search, and many of the phytoconstituents are available here. Environmental deterioration, concentration, soil adsorption. See the amount of depth they have gone to in curating this, where all it occurs and at what concentration. So you can just say that this quercetin or its glycoside is present in apple at this concentration, pear at this concentration. Otherwise it's difficult to search it paper wise. And see some literature, like I said, you can see this is just a page 1 of 9300. So imagine how much they have to offer us in terms of literature. So more about 5000 more pages you can search where you will get the literature pertaining to that. Wiley references, nature journal references, chemical co-occurrences, if there any other flavonoid which is very structurally reactive. Then you have your gene co-occurrences, chemical disease co-occurrences. Post the literature you have patents. What all patent have been filed for quercetin, which has a mention of quercetin. So all those patent data will be there where all the quercetin name is mentioned, it will come here. And then also interaction data. Is quercetin studied in terms of its binding ability with certain receptors or proteins? You can even download those from here. So again, if you see, there are 7 pages with different receptors wherein your protein receptors are complexed with quercetin. The ligands, the interactions with different genes. Again you can see the amount of data that comes on your PubChem. It's almost 1551 kind of searches or queries it answers to. And then biosynthesis. So if you want to know how it is biosynthesized, that detail is also there on this database. Bioassays, the taxonomy, where all it occurs and what is the taxonomy of that, the MESH terms which helps you in literature, the lipid, KEGG, phytochemical compounds, KEGG. So all in all, if you go to see, this is kind of a very elaborate database. Just search the compound and you will get a complete history about it. But we are not stopping here. We'll move to the next database which also has some details about it. And let's go to the next database, and that's your zinc database. So again in this I'll raise the same query and let's see what zinc has to offer. Zinc NPACT is zinc natural product database. So let's see which are the structure. Now you can see it has come back with 3 queries. The little difference between this is the first structure is racemic, and you can see the other ones are the optically active ones. So let's just click on the racemic one to see what they have to offer us. NP Atlas database is another curated database for phytochemicals. So it contains properties of most of the phytochemicals with respect to their structures as well as with respect to their pharmacological activities. So let's search, or let's put in the query for our compound and then search whether it has to offer something add-on in comparison to the previous softwares. So here in this case, I'll just kind of raise in my query in form of structure. So let's kind of draw our quercetin. And then let's try to search. Now you can put it as a full structure or you can put it as substructure. What you say is, when you say a full structure, I want precisely like this. But when I say substructure, it would include any molecule which has at least this in their structure and may have more add-on functional groups. Then I can check for similarity in them. The threshold is the substructures or the structures that come in should at least be pointed, that means 80% matching to my query. In addition to that, I can just write the name, or I can give in the molecular formula, chemical formula, or INCHI keys. Okay. So in this case, I am just putting all the properties and just submitting my query. So here you can see definitely a quercetin structure is there, but in addition to that, you can see there are some additional groups being there. And here in this case, it's quercetin, but you added a methoxy out here and a glycoside out here. So this is few add-on products that has come out back with. So this is the name of the compound. I can just go there. I can download the structural properties from here as SDF options, which will give me the 3D structure as well, the mass and other properties. Now what I can do is if I want more of this, like more of a similar flavonoid kind of structures, I can give a little incomplete structure. Say for example, I am not very keen on quercetin, but I want some flavonoid. So, I will just give it the flavonoid nucleus rather than giving a entire flavonoid. Let us see then what happens. So, this is just the part of nucleus that I am putting in, and then I tell it to submit the query. So, this time it has come up with 17 compounds which has it. The reason is I was this time not much specific with the hydroxy substitution. So, there is a good chance that if I am having this kind of nucleus, any of these compounds can also be there. So, NP Atlas kind of gives you an idea that if this particular characteristic pharmacophore or structure is there, what are other possibilities or what other possible structures are there that you can abbreviate. Now, moving on to the next one. Here this is a software which is called as NP Scout, and that helps you what is called as predicting the drug likeness. Now, many a times after purifying the molecules, you might come across or you might derivatize certain structure based on its spectral properties. Now, post that, is that molecule naturally feasible in plant or not, we can do it or we can check it here. So, what we need to do is, say for example, based on the spectral characteristics, I found out that this could be my molecule. So, is it a natural product like molecule or it is not a natural product like molecule? I can just find out by doing this. So, again I raise my query as quercetin and let us see what happens. So, it says NP class probability once means full probability that it is a natural product, it occurs in nature, and majority of the areas where the heterogroups match are marked with green coloration. So, any time after spectral derivation you come across a structure, and if you want to see whether it is actually occurring in nature or you have drawn something wrong, whether it is naturally possible or not, I can understand by doing this. A good score is NP class probability of 0.9 and above. Then we move on to the next database. Here also we can see dictionary of natural products. So, I just have to draw maybe pharmacophore and then just see whether it is possible or how many such natural products are possible. Again I go back with a little raw query. I will not give it a full structure, and then let us see what this software comes back to me with. I will just give it 1 hydroxy for convenience and then let us see. So, what I am putting here is in the dictionary how many natural products have this kind of structure. Okay. So, let us see and search. So, you can see the total hits. In nature there are 7,212 molecules which had that particular structure, and here is the list of all those molecules. So, the dictionary of natural products based on the structure that you have curated will come up with all the possibilities and all the structures. So, this is very important in terms of pharmacological activity or whenever you are doing docking studies. I want a particular molecule with this pharmacophore. So, how many molecules are there in nature which possess this particular pharmacophore? So, just put that pharmacophore in your dictionary of natural products, it will come across this many compounds. So, you can use this structures in docking, and then you can optimize that which natural product will react well. Okay. Now, in addition to that, you also have your Lotus. Here you can directly put the name as query. So, I am just putting, and then I click search. So, there are so many molecules, about 32 natural products which have quercetin in their structure and plus R add-on. So, Lotus also gives me all the molecules which will have that, a very similar manner to your Atlas, and as a result that will be very useful for me in terms of prediction of properties. If I just put my native quercetin here, let us see. So, I start getting properties of it, not as much as in depth as your PubChem, but yes, I get something which is called as the link to taxonomy. So, if I say it is found in Vitis vinifera, so which all plants in that particular taxa have it, is how they see it. So you can just click on one. Let's click on the Vitis vinifera, which is nothing but your grapes. So you can see in Vitis family it occurs in this all places or this all families. So your quercetin per se, here also you know how many plants contain this. Not only that, in that family how many plants contain this can be obtained via your Lotus database. So this is, you can see, a very exorbitant list of so many plants containing your quercetin as a molecule. So it's just huge, and that's where you say, if I want to see quercetin which all plant contain, when I am trying to find the source, Lotus is a go-to software which can help you out. So quickly summarizing it back. So today we learned how to use natural product databases to see the properties, both the physical as well as chemical properties of the drug. The softwares include, or the web-based servers include, your PubChem, Lotus Natural Product Database, your Zinc databases, NP Atlas, Dictionary of Natural Products, and NP Scout, which will help you predicting the natural product likeness. So thank you everyone for listening, but I want you all to check putting your phytochemicals in the queries and seeing if you are actually able to assess all the properties through all these softwares. When you try to do it yourself, maybe you will discover a lot of other things you didn't know about your compound. So happy learning all of you. Thank you.